So basically, capacitance, it's a capacitor. It's designed to store charge. So as you switch on the voltage, then the electrons would be pulled towards the positive terminal of the battery, and electrons would be pulled towards the positive terminal of the battery, which means it would leave that plate of the capacitor. So as soon as you switch on the battery or the power supply, it's going to, so this part of the battery is going to be positive, right? And that's part's negative, so positive, negative, and so it's going to be attracting electrons to that plate from the positive. From that plate. So that plate of the capacitor will start off being neutral, and it would gradually, as it loses electrons, it would gain them, start to move them over here. But to start off with, it'd be quite easy to remove electrons from the plate. So when you are trying to charge a capacitor, you'll get a graph that looks a bit like this. So it'll start to charge very, very quickly. That's actually a potential difference, but same would apply. It's essentially the opposite of this graph here. I'll draw it. I thought we already did draw it. We did draw it down here. So it will start to charge very, very quickly, and then it will start to get harder and harder and harder because you're trying to remove electrons from something that's quite positive. Okay, so it's being pulled around here, and then it would essentially go all the way around the entire circuit and land at the other side. Well, to be honest, the electrons that do gather here, I suppose you could redraw that part of the circuit, imagine it as one straight line. In fact, this is a good way to think about it. I did see somebody explain it this way. I quite liked it. So let me explain it this way. Let's imagine the circuit is not a circuit, but just one line, like with a plate at the other end. As soon as you turn the switch on, then because that's positive and that's negative, then you're going to be pulling electrons that direction, and then this would make that end of the wire a positively. Okay, and then on the other end, you're going to be pulling. You're going to be putting electrons that direction, so you're going to be piling up electrons on this end. So that's what would happen. Oh, sorry, it's just sync. So it's just that would happen. Now, if you actually connected these up into a loop, so as the either end are very close to each other, so instead of it looking like that diagram I just drew there, it would actually look like this diagram. There's nothing in terms of the electron flow. There's no real difference. That apart from you are going to be able to gather more charge now, because once the electrons flow towards that end, so this is electron flow I'm talking about, not conventional current. That's the capacitor down there. That's the battery up there. Then, so in the same way, you're going to have, this is going to be positively charged. That's going to be negatively charged, but the capacitance will be larger. In other words, you'll be able to build up more charge in the below one, because what happens is when the electrons start to build up on this right-hand side, they're slightly, although they're repelled by the other electrons that are already on the plate, they're slightly attracted to the plate that's just behind it. So if we say that's plate, so just to make it a bit easier to visualize, let's zoom all the way in, and we can say that's plate A, and that's plate B, and we would say, look, maybe write a sentence that in the middle of it, electrons are repelled by the other electrons already on. I'm just going to shrink it so as it fits. Already on plate A, but are also slightly attracted by the positive charge on plate B. So by bringing them close together, you're going to be able to put more electrons on that plate A, and also in the same way be able to pull more electrons away from plate B. So that's why, in other words, the closer the plates are, the higher the capacitance. Okay. So because let me if I redraw plate A and plate B really big, and then just focus just on that part of the circuit. So yeah, oops.
Oh, the surface area. Okay.
No, I'm not talking about surface area at all at the moment. I'm only talking about the distance between the plates. So,
but it's an inverse relation.
Yeah. It's an inverse relationship. I'm saying the smaller the gap, the larger the capacitance. Yeah. So that's the Y going to it. That's the Y going that way. This is positive. This is negative. We are. So let's see if I can draw some little electrons. Let's say that's an electron, or that's an electron there. Just draw it, just collect it, group it, and I think I can do this. Yeah, we can just start pulling them on there like this. Now, on the one hand, when as I'm trying to put more of these on, the next one is going to be repelled by those, right? It's going to be harder to put this one on there than it was the earlier ones, of course. But luckily, so the reason for that, of course, is because they're pushing them away. There's a force that's repelling them. Okay, so maybe it would be better to draw the force. I'm trying to pull it to the left, but there's a force pushing it away due to repulsion. But of course, on the other side, there on plate. So that would be my plate A. But on plate B, there's a lack of electrons because we've removed them, and so because of this positive charge, and we can say, in fact, we can use a little subscript there. Because of that repulsion force, we can say that's the force of plate A. But we've got maybe we could use a different color as well. So let's say that is plate B. And now we've got a slight attractive force of plate B. Okay, so then the resultant force is obviously going to be overall smaller. So the smaller the gap. Let's zoom out so as we can draw our gap. So this gap here, D, the smaller the gap, the smaller the distance B, distance D, I don't know why I said B, distance D, the larger FB is. Yeah? Because as you're getting closer to it, then the positive charge is able to get closer and produce an overall larger force. And with the larger, so this then reduces the resultant repulsive force. Does that make sense? I think I explained it okay at the end.